Hello friends, so today I thought I'd talk about this paper exploiting Cloze question for future text classification natural language inference. So often when we try to train a domain-specific model, we're faced with the problem of limited amount of labeled data. And by using this training procedure, it allows us to leverage the pre-trained language model and then to distill the knowledge from those language models like BERT, GPT, or Roberta, and to create a much larger training data set. So a bit like data augmentation. So the core idea of this paper is reframing the classification task, test classification tasks as a language model tasks. So what we mean by that is, for example, if we see here we've got a statement best pizza ever, the sentiment is +1, and we input that to our language model, we phrase that as best pizza ever, it was, and then we want the language model to fill in this blank. And then hopefully the language model will give us great with a high probability and bad with a low probability. We can then map the output, the grade, to our positive sentiment +1 and bad to a negative sentiment. After we've got the model here, we can now go about labeling our unlabeled data sets, which creates the set of sentiments here as well. So as you can see, over time, we've got a bigger data set, and then finally, we can train a classifier which is used for our ultimate downstream task. So the paper called this training procedure as the pattern exploiting training. And we've got a set of PVP, the pattern verbalizer, and pairs. What it means is, for example, here we've got pattern A question mark blank B. For example, Mia likes pie question mark, and then we've got blank. We want to fill in the blank here, and then Mia hates pie. So this is the pattern here. And then the verbalizer 0, for example, will be mapped to yes, and then verbalizer 1 will be mapped to no. So once we've defined the pattern, how do we go about training it? The paper outlined 3 steps in here. And if we look at the diagram below, so for each pattern, we want to train our different language model. For example, this could be BERT, this could be Roberta, this could be GPT, and we want to train that on, we want to fine-tune that on our limited amount of training labeled data sets. Then after we've fine-tuned our models, we can now go about annotating our much larger data set, unlabeled data set, and create what the paper so-called the soft labels. So here we've output a bunch of labels from our fine-tuned model ensembled models. And if we ignore this bit here for now, so all these labeled data set will then form our kind of final training data set, which we can use to train our final classifier on it. So the author also say, so this will be one pattern exploiting trainings step, and what the author suggests is that we have an iterative step with each one after we've got our soft labels, and then we introduce more unlabeled data sets. So you can see time over time we've got more and more training data we can use then for fine-tuning our final classifier. So by using this semi-supervised learning, the author find that even with a very limited number of training samples, we're able to outperform a supervised method. For example, pets here, 60 on these Yelp dataset, on this different dataset, and then the iterative version even outperforms better. Why do I find this paper interesting is because very often when we want to do some fine-tuning or domain-specific problems, classification problems, we often face with the problem of not enough dataset. And by using this PET approach, we're able to generate much larger training dataset, which we can use to fine-tune, or we can use it for our downstream tasks. So yeah, I hope you find this useful, and if you're interested, feel free to check out this paper here.